Question number 4. The speed of a car traveling along a straight road decreases uniformly from 12 to 8 meter per second over a distance of 88 meter. So we have to calculate the acceleration of the car, the time taken for the car to travel the distance of 88 meter, total duration of the whole journey if the car continues to decelerate at the same rate until it stops, and lastly the total distance traveled by the car until it rests. Okay, so from the statement, what we can know is we have the distance, which is we can let distance to be s atau dia. So for this part, we are gonna use s because there is gonna be it should have direction. Okay, so for this part we're gonna use s, which is 88 meter. You have the initial velocity, which is 12 meter per second, and the final velocity, which is 8 meter per second. Okay, so we have to calculate the acceleration of the car. Remember, we have v square u square plus 2as. We have v equal to u plus at. We have s ut plus half at square. What else do we have? That's the most important equation lah. Okay, so the acceleration of the car, we can use either of these equations. So it depends on what information is available lah. Okay, so the acceleration of the car, from this part we have s, u, and v, so we can only use this part because these two equations require time. Okay, so let's do that. So we can use v square u square plus 2as. So we have acceleration to be equal to v square minus u square divided by the twice the displacement, the distance. So this is gonna be 8 square minus 12 square divided by 288. So you will get negative 0.455 meter per second square. So that is the acceleration of the car. And then we have to calculate the time taken for the car to travel the distance of 88 meter. So now we are looking for the time. So we have the acceleration. We can then use v equal to u plus 80 because we are looking for the time. So time is just v of minus u divided by a. So we have v, which is equal to 8 minus 12, 0.455. So we'll get 8.79 seconds. Okay. Question C pula, we have to calculate the total duration of the whole journey if the car continues to decelerate at the same rate until it stops. Okay. So now until it stops means that the final velocity will be equal to 0 meter per second. Then the initial velocity masih sama lah, 12 meter per second, and it is decelerating at the same rate, which is 0.455 meter per second square. So from here we can then use v equal to u plus 80 juga lah, because we are looking for the time until it completes the whole journey lah, until it goes to a stop. So minus 12 divided by the acceleration. So this is equal to 26.4 seconds. Okay, let me just redo that. Alright, so that is question C. Question D, the total distance traveled by the car until it rests. Okay, until it rests. So we are looking for S. So if we are looking for S, we can just directly use ut plus half at square. Okay, so why are we using this? Because we have all the information. We just have to substitute lah. So u is gonna be equal to 12 meter per second. Time is the one that we've calculated earlier, and plus half, acceleration is negative 0.455. T is 26.4 square. Okay, so the total distance traveled by the car until it rests. Since we are looking for the total distance traveled, we are going to use the total duration of the whole journey. Okay, so that is 26.4 seconds lah. So S is gonna be equal to 158.24 meter. Okay, so that is the total distance traveled by the car until it rests. Right, so that is the solution for question number 4.